So I'm going to talk about Redux Saga and generators. Yeah, they indeed sound fancy and kind of boring and a lot of technical jargon, but I'm here to sell this thing to you guys to open a new world of possibilities. It sounds all magical. This is particularly an esoteric side of JavaScript which very few people like delve into. So my name is Kushan Joshi and I work at Mapbox. I get to work on OpenStreetMap in this ID editor that we're working on. And you can follow me on Twitter, Kushan2020. Right. So let's just get started. So what are generator functions? Has anybody heard about generator functions before? Okay, cool. So I think there are like 5 people over here who know about generator functions. So my talk is going to be quick. I'm going to really dive into the 5th gear and just start. So you can just have an adventure here. So generator functions are functions which hold state, and they can be paused and resumed on demand. Now this idea is very foreign to JavaScript, since in JavaScript every function runs to completion. You won't find an exception where a function does not run to completion. The moment you call a function, it just runs. Until now, generator functions do not run to completion. The moment you call them, they simply wait. Should I run or not? So you can think of this monkey guy as a generator who's lazy. Now let us look at a simple example of generator function. This is a very trivial example. Over here you can see that there's an asterisk which denotes that this is a generator function, and it kind of looks like a function, but it is not exactly. It has a yield keyword which tells you what this generator function is going to return, and can return multiple values. As you can see, there are multiple yield over here. So how do we exactly call this function? You simply call it like a regular function. There's no difference. The only difference is the moment it gets executed. Nothing gets executed. It just returns an iterator. So the moment you call a generator function, your function body is not executed. It returns an iterator. And what exactly is an iterator? Now iterator is another fancy term introduced by ES6. It is a sophisticated and a safe way to iterate through a data structure. Sometimes you don't know what the data structure is built of. So they simply launched this protocol in ES6 which tells and unifies how to iterate through a collection. So every iterator would have a next function inside it. That's guaranteed. If it's an iterator, it would have a next function. And that next function would return something like this on the right hand side. You can see that sheep is like a way of collection. It will have 2 properties, which will have a done key and a value. Now done tells you whether the collection has finished or not. It's a safer way to tell whether your collection has iterated or not. And the value tells where your current iterator is. People familiar with databases might think of this as a cursor. Now JavaScript has this. You can use this technology with arrays, string, map, set, type array. It is all built in, battery is included, and all can happen in your browser. You don't need any extra library for this. So coming back to our topic of generator, how do you actually get the value 5? You simply call it by it.next, and this will give you a value 5, and it will tell you that it has not finished yet. Done is false. You call it again. This time, as you can see, it gives you 6, and the next time it gives you 7. Now things get interesting. Since there's no yield, next time you call it, it will simply give you done as true, and the value would be undefined. Now this is your way to just stop the iteration. And for those curious who are thinking like, what if I call this thing again and again? It will simply give you the same thing. Value is undefined and done is true. So you can do a lot of fancy things with generators. Over here you can see I am creating an array using the spread operator. It gives me a 5, 6, 7. I'm using the new for of loop, which is compatible with iterables, and this would print 5, 6, 7. So in short, generator is a nice way, and I find it the most easiest way to generate an iterator. Other ways are very, very difficult to understand. So let's get back to Redux. How does generator fit with Redux? Let's look at a simple Redux store, a very, very simple Redux store. You have an action and you have a store. Now the action over here is an airplane and the store is a barrel, as you see. Now things get complicated. You have more actions of different types, different names, right? But you still just have one store. And actions dispatch, your store changes, and people who are listening to the store react to it. Your components can react to it and other things can react to it depending on the store. So this was the story, and it is all simple and it is all nice, provided you are sold with the Redux thing. Now things get complicated when you have this cute little thing called async action. Like the moment you step in with asynchronous things, things just start boiling. I mean, it's crazy. A lot of people find asynchronous difficult and not easy to understand. Like, it is actually quite weird because we are familiar with the way code steps down, and in JavaScript, from anywhere callbacks come and something starts executing. So how do we actually tame async action? By design, Redux does not allow you to have asynchronous actions. Redux does not allow it. Your actions have to be synchronous. So as developers, we build tools for it. We have this nice thing called Redux middleware. We create fancy tools. Every other day, new tool keeps on coming, all sorts of tools. I mean, there are a lot of Redux middlewares that you might have seen. Like, there are so many, and every day one or the other keeps on coming. Like, there's no end to it. Like, Redux Gun, anybody? Yeah. So one of them is this generator back thing called Redux Saga, right? So this cute little chimp over here represents Redux Saga and generators, depending on the context. So what is Redux Saga? It is a library which helps manage async actions with the help of generators. The concept that I just introduced to you guys. You guys must be familiar right now. So it just does two things. It runs the generator function for you, and it gives you a helper function to interact with Redux. That's all Redux Saga does for you. It will run the generator function, and it will give you some helper functions which make your life easier when you're interacting with the Redux store. Let's get into the code. I love showing code examples. So this is a very simple Redux Saga example. Over here you can see this is a generator function which we call a Saga marketing, and then there is this line is called yield, and you might be familiar with this. But the interesting thing here is the take. Take is a helper function provided by the Redux Saga library. It allows your Saga to listen just like reducers. So somebody dispatched an action called start. Your Saga can listen to it now, just like your reducer. So now you can see the power of Redux. So the moment somebody dispatches a start action, your Redux Saga resumes your generator and it jumps to the next line. Now all of this is happening asynchronously. The moment somebody dispatches a start, then only the second line is revealed to the computer or you, right? And the moment you reach the second line, you see another helper function over here that I have written. It's called delay. It's just a glorified version of set timeout. As you can guess, it delays the execution by 1000 milliseconds. And the moment 1000 milliseconds elapse, as you might have guessed, generator function resumes its work and gets to the next line, which deals with the store. Another helper function, which is put. This is similar to dispatch. And over here, I'm just simply dispatching an action called done. As you can see, these three steps simplify the asynchronous way of dealing things. You did something asynchronous back there, and then finally you tell your store, hey, everything is done. You can do whatever you want. Like, I'm using put over here to dispatch. So how does it compare with Redux Thunks? Everybody might be familiar with Redux Thunks, right? I think 50% of the people, I guess, right? Yeah. So let's see an example of Redux Thunks here. I'm going to implement a login. You can see it's a thunk. It will return a function. And I'll do something very asynchronous inside it, like a login with user and password. And then I'll dispatch. Once that action is completed, I'll dispatch logged in. And if something fails, I'll simply dispatch login failed. That's how you do it in Redux Thunks. And it is quite simple and not that complicated. But when you jump into Redux Saga, this is how it looks like. Now before you guys scream like, why is there a while with a true inside it? It might end up in an infinite loop, right? Yeah, it might not, because it's a generator function. And generator functions simply stop the moment they encounter a yield. So this while loop will not run into an infinite loop, and you can continue doing your work. So what happens is, Redux Saga sees this, it stops the execution. And as you might have guessed, it will wait till a login request is dispatched. Like somebody dispatches the login request. And the moment login request is dispatched, this generator function resumes its work. That's what generator functions are for. They resume their work, and it gets to the next part, where I do the asynchronous part. I am calling the server, and I'm telling him that this is the user and password. Can you log my user in? And even here, it will wait for it to happen. And the moment server replies, I get the data. All of this looks quite synchronous, right? So why not wrap it into a try and catch? It's the synchronous way of doing error handling, and you can simply do this with generator functions. If something fails, your network request fails, you can simply catch it and dispatch an action which says something went wrong, in this case login error, and your store or anyone who is responding to it will adapt accordingly. Now at this point we are in feature parity with thunks. This code is exactly doing what this thunk code is doing. Isn't this just too complex for a login? Now a lot of you might be thinking that it might be too complex. I agree with you. This is indeed too complex. There's a burden of generator and there's this whole while true loop, but things are not really that good in the real world. You might want to load user details after you have finished a login request. You might want to log out that user. You might want to figure out how to do the login. And then you might end up in a race condition like user started login and the user happens to be an impatient one like me, and he presses the logout button and your app simply dispatches a logout button. But the problem is authorization hasn't yet reached to us and your app gets into an inconsistent state, right? This is a race condition in network. So how do you exactly deal this kind of problem simply in Redux Saga? You get back to our example. We have the same take login request. We try to do that network request where we log in the user and your user gets impatient. He says, log me out, and he dispatches an action somehow. He says, just log me out. But Redux Saga is not at that point. There is no take logout request. Redux Saga is simply going to ignore it. There's no way that this suspended generator can take that request. There's no code for that. And then that request gets ignored and your user just simply waits, and then you get to the login success, which is when the server responds, hey, everything is good. And then our code is ready to take the logout request. At this point, if the user clicks logout, he can log out easily. And as usual, if anything goes wrong between this, you can simply catch it with an error and dispatch a login error. So this is how you do asynchronous action and login and avoid all sorts of crazy Redux action and thunk problems. You can go way too complicated with this. You can add a load user detail, you can do a cleanup, you can just keep on adding, it all seems synchronous. But problem is, what happens? Why can't we just use async await, right? Is everybody familiar with async await? Yeah. So why can't we just use async await? Why are people investing so much time in understanding this whole concept of generator, functions, Saga? Like, if somebody had to write Redux Saga with async await, this is how it's going to look like. Am I wrong? This is how it's going to look like, and the whole point is like this is much more readable and much better at understanding what is going on. So is my talk useless? Are generators useless? Or is the whole Redux Saga going to port to async await? Is that what I am implying? No, there's a cliffhanger, right? The whole point of generators is that you can manipulate them while they're suspended. I didn't tell you this part. You can manipulate them. So imagine this is your generator and this is Redux Saga, which runs the generator, right? So Saga says it.next, and your generator replies with something good, an apple. Saga says it.next, and this time, generator, the world is unpredictable. Generator doesn't reply with something good. Let's say in this case, a scorpion. And Saga just freaks out and says, oh no. And over here is the part where the runner can send a message to the Saga. Over here, I'm sending the reset param inside it. So this is a way of doing a communication between the runner and Saga. And if you have written a code for handling reset, generator can get back to the work and you can have a two-way communication between the runner and Saga. Now compare this with an async await function. The moment you start an async await function, there's no point, like it will eventually execute. There's no way you can tell that guy, dude, can you change the course? Can you maybe take a left turn? Can you take a right turn? You cannot. Async await functions, you once executed, they just keep on running over a period of time and eventually get some output. So that's the whole point of Redux Saga. It is easy to test and it allows for communication at every yield point. How do you exactly test Redux Saga? Over here you can see that I'm having a regular assert statement, and instead of Redux Saga being the runner here, I am running the Saga myself and I am calling it gen. And the best part about this is whenever I do gen.next, I get the value and I can do an expectation over here. I can check what value is my generator returning, and I can avoid all that asynchronous stuff and just expect whether the value is delay 1000 or not. I can check whether generator has finished or not, or I can check whether the value is put type increment, whether the generator is dispatching after this action or not, and I can eventually check whether the generator finished or not. There are lots of possibilities with generator function with Redux Saga, and this was just a brief glimpse of that. So the takeaways: generator functions are fun, and they're not just to get away with the asynchronous problem. They have this whole communication thing between them, like the person who runs the generator function and the generator function, they communicate between each other. And Redux Saga exploits this very part of communication, and it is an amazing solution to the async action problem. And I guess after this talk, you guys would love to jump into Redux Saga and look at the various possibilities over there. Thank you.
Hi. Is there any other use case apart from the race condition that you mentioned? Because like if I want to move from Redux Sync, which I use currently for async, like why should I move to Redux Saga?
So, yeah, good question. Like the possibilities are enormous. Okay, so the race condition was one of the very tricky example which I guess everybody would have encountered. When there are two promises and what if this one finishes first or not. But Redux Saga provides you a lot of tools. Like I guess there are like 25 to 30 helper functions, from forking to other sagas listening. Like another saga can listen for a dispatch event while the other saga dispatches it. So the possibilities are endless. You can totally orchestrate any kind of asynchronous action system that you imagine in Redux Saga. Any kind of possibility. But with Redux Thunk, it just gets complicated at just right that point. When we were doing that trivial Redux login example, that was the best part about Redux Thunk. It was simple. But the moment you start adding more things, more actions, and more cross communication between actions, especially asynchronous, it gets kind of weird. So Redux Saga just helps you tame that and keeps things under control. And the best part is you get to test every inch of your action. Like every asynchronous action, inside that, every step you can test. You can't do that very easily in Redux Thunk. Your boss would be happy when you're writing more tests.
Hi, great talk.
Yeah.
So this can be treated for use cases where you need a state machine and you have one after the other. Is that a good use case?
State machine as in the physics thing where?
No, the usual state machine.
Redux statement? Yeah, so this thing builds on top of that you're ready to get into the deep water of Redux. Like you're already onboarded with Redux and you have embraced Redux and now you're having problems with asynchronous actions. Okay. And also on top of that, async actions are going a bit beyond complexity. If they're not up to that complexity, you can simply not go to Redux Saga. And even if your application state is not that complex, you can simply avoid Redux. There's a step-by-step thing. Once you reach that threshold where the water is boiling, frog has to jump out, please use Redux Saga.
Can it work with Thunk?
Yeah, but I would suggest to just not use Thunk. I mean, this.
Hello.
Yeah.
So one of the advantages I felt of Redux Saga was we could separate out the async effects that is happening. And like if I were to use Thunks, my view layer would have the actual API call that is going to happen. If I have sagas, like that's
I feel that's a separation of concern there.
Yeah.
But do you think we are losing the flexibility that Thunks provides? Say, for example, I need to show a loader. If I'm using Thunks, I would just set my UI state in the component itself. But if I'm using a Saga, I need to maintain a Redux action for that and move that logic as well to the Redux store, which is actually just a UI state. So Thunks, if I'm using only my application logic, would be in the store, and I would be changing my UI state based on the dispatches or in the Thunk itself.
Yeah.
In Saga, as we are completely cut off from the view layer, we might need to do that in the middleware.
Yeah.
So do you think that we are losing the flexibility of Thunk there?
Yeah, I get your point. So yeah, you're correct. Like it depends on the way you define flexibility. So over here, you are abstracting away the actions, asynchronous, and all the ugly stuff to Redux Saga. The Redux Saga thing that I didn't tell you guys about is that it handles side effects for you. That is another talk, for the whole side effects thing. So basically, it does the dirty work for you. And again, there's a threshold. Like if your application is just about showing spinners and mutating small UI elements, you shouldn't even go for Redux. But the moment it's a big application and there are a lot of asynchronous actions which are dependent on each other or their cross communication, you will have to find for a solution which is better than Thunks, right?
Thanks, Kishan.